Hello? In this lesson, we'll build the final scene, and we'll have to write a lot of scripts. As a result, we'll have several different scenarios of the character's behavior that depend on the situation. For example, the character can be controlled by the player, run along the finish line automatically, and dance at the finish. Let's start with a script that controls the character's behavior. That is, it'll switch between the three behaviors. I'll create a new script in the scripts folder and call it player behavior. I'll assign this script to the player. Here's what we'll start with. When we launch the game now, the player can run immediately. But I want to make it so that before pressing play, the player can't run but just stands and doesn't do anything. How can we stop them from running? We can just disable the player move script. They won't be controllable, because they're controlled and they move in the player move script update. Let's do it using player behavior instead. It will be responsible for switching on the scripts. So let's add a link to player move here. We'll call it the same, just with an underscore. And disable it in start. Underscore player move dot enabled equals false. This command turns the option off in the component, in the inspector. Then we'll need to turn it back on at a certain point. To do this, I'll create a new method. Type public void. Let's call it play. It'll turn the option back on. Underscore player move dot enabled equals true. Leave it at that for now. In this lesson, we'll add more things to this script and describe different behaviors in it. The play method must be called when the button is pressed. What does pressing the button do now? It calls the play method in Game Manager. Let's add something else here. For example, Game Manager must find the player in the scene. There's only one player, so if we use the findObjectiveType method and find the player behavior component, we can call the play method. Architecturally, this isn't an ideal solution, in terms of code, because we just look for objects in the scene by type. But it works perfectly fine for this task, so it's okay. Let's add a link to the player here. And now they can't run. The option is off, but when I click play, the player starts running. Okay, this is cool. Now let's move on to creating the finish line. The player will run through curbs. The idea of the finish line is to run through such curbs. At the beginning, they reduce the character's height, and when that is sufficiently reduced, they begin to reduce the width. The task is to run through all the curbs and reach the finish. But they may not reach it if they're too short and thin to go past a certain curb. First, let's create the curb that reduces the character's size. I'll create a new script and call it barrier. Let's create the object too. It'll be a brick wall. I'll create a new cube and stretch it so that it's difficult to run through it. So that you can't get around it. I'll add a script to this object. Select the trigger option, so that when the character interacts with it, the curb is destroyed and the character is affected. I'll get a nicer material for it later. Go to the barrier script. We need the onTriggerEnter method here. Again, we need to check who exactly enters the barrier. We need the player modifier component. Check which rigid body is attached to the object that entered the trigger. From this object, we then get the player modifier component. If the component is there, if there is something in the player modifier variable, we refer to it and describe the behavior. When the character hits the barrier, they must first change height, and when that reaches 0, gradually change width. Let's go to Player Modifier and write one more method in addition to add width and add height here. We can call it hit barrier. For example, if the character's height is greater than 0, we'll reduce by 50. That's it, actually. If the width isn't 0 yet, underscore width 0, we'll reduce the width. Underscore width dash equals 50. Pay attention. When we change the height, because everything works in update, we can immediately see how their height changes and how their back moves. But for the width to change, we also need to call this line right here. It isn't usually good practice to copy such long lines with some logic in them. So let's be a little more careful. I'll create a method void updateWidth. Let's call it updateWidth. The method will have this one line, and instead of copying it, we'll just call this method. It's convenient because if you suddenly decide to change anything, for example, the name of this line, you don't have to change it in 2 places. It's a sign of bad programming if you have to change something in multiple places. If the height is greater than 0, we reduce it. If the width is greater than 0, we reduce it. If the character is already short and thin enough, they must lose, and we'll destroy them. I'll create a die method and call it from here. The die method will simply destroy the game object. Let's check how the player runs through the curbs now. Wow! I made a mistake somewhere. You see, if you make a mistake, the console shows it immediately. You can double-click here. Ah, yes! I just forgot to call this method at the barrier. Hit barrier. The method must be public. It must be marked with an access modifier, because we want to access one script from another script. Let's reproduce some situations so that we don't run through curbs for too long. Let's run through the first gate. The character will gain height, and then they'll hit several curbs. Let's say this gate adds 300 to their height. The gate doesn't look good with this figure. Let's adjust it a little bit. Just make the font smaller. Okay. Let's simulate what happens at the finish. Let me name this cube right away. Barrier. We can assign some interesting material to it, and it'll obviously have the same name. It mustn't be shiny. Something like a brick wall. That's it, we have the script and the trigger. Let's copy and paste a few walls. And let's see how it works. The character grows and runs through curbs, and every curb reduces their size. Everything's okay, but I want the curbs to be destroyed. Later, we'll study particles and destroy the curbs in a cool way, smashing them into bricks. But for now, I'll add destroy game object here so that it just disappears. And let's see what happens if, after all, the character isn't tall enough and gets killed against one of the curbs. Yeah, they just disappear and get destroyed. When you destroy an important game object like this, expect plenty of errors. because something most likely refers to this object. In this case, the camera can't find who it must follow. As you can see, the camera script says missing transform. The player is gone, there's no player anymore, but the camera still tries to find the player's position and follow its script. To avoid mistakes, it's important to correct this. The target must be followed only when it exists. Make sure there are no red errors in your project. Now it's all right. Nobody else refers to the player. In general, I've noticed that some beginners are unfazed by this. They keep working when there are thousands of red errors here. Right now, the player died, everything froze, nothing moves, and you might not care whether there are any errors, because it's over. However, in general, it's still wrong when the program works with errors. At the very least, they bug you here and you can't just look at the console in the normal way. All the same, it will eventually cause something bad. It means that the program works incorrectly. Let's also simulate finishing here. That's okay, I'll delete these things for now. The idea of the finish is that the character breaks through barriers, as it were. They also collect coins. The finish line looks exactly or approximately the same on every level. Let me create a new empty object and call it pre-finish or something. Or let's just call it finish. It's a finish line that leads to the finish. It's convenient to set y to 0, so that the center of this object is at 0 coordinates, and I'll link all the curbs to it. Here, this is our finish line. There should also be coins in it, so you can take the coin prefab and drag it here. I'll place it at 0, and then I want to build something like a tower of coins. The idea is that the character is tall at the beginning, then they grow smaller and can collect fewer and fewer coins. But the taller they are, the more they can collect. So the player has the motivation to grow. Something like this. There'll be coins after every curb. There's a cool effect when the player gets a bunch of bonuses at the end of the level. That's what we'll implement now. Another thing I want to do is make the character run automatically at the end. That is, when they run along the finish line, we can no longer control them. They just run along the center like this. Let's implement this behavior right now. To do this, we need another trigger. I'll create a new box inside the finish object and call it pre-finish trigger. A trigger before the finish. Let's put it here somewhere, and when the character hits it, the movement script will be disabled and the automatic running script will be enabled instead. We had very small details in this lesson, but you can't do without them. I'll create a new script for this object, call it pre-finish trigger, and put it on the box. We'll use the onTriggerEnter method here, too. We also need to check whether the object that hits the trigger has the player behavior component. If it does, the player behavior mode needs to be switched. Let's go back to the player behavior script and create a new method here. I'll call it start pre-finish behavior. It's what the character will do before the finish. Control turns off, and automatic running turns on. First of all, we turn off the control _player move.enabled equals false. Secondly, we need to describe the automatic running behavior. Let's create a separate script for this as well. As a result, the player has multiple scripts, and every script is responsible for their behavior. Player move is for controlled behavior, and the script that we'll save now is for automatic running in a straight line. I'll call prefinish behavior. Let's think about what should happen here. First of all, they just need to run along the z-axis, which goes in that direction in the world coordinates. They must run along this axis at a constant speed. So we take the player's position transform.position and add to it a vector where x and y equals 0. As for z, let's say they run at a speed of 3 meters per second. Multiply 3 by time.delta time. As I said, for the number not to depend on frame frequency, it should be multiplied by time.delta time. They'll run at a speed of 3 meters per second along the z-axis. Actually, you can already see the result. The idea is player behavior must also have a link to this script. Disable player move, but enable this one. Enabled equals true. There. Disable it at the start, too. Enabled equals false. Of course, you can disable it manually in the inspector in advance, but this way is more reliable. Let's see how it looks in the engine. Add the prefinish behavior script to our player. Add a link to it here. You can change the script order to make it more logical. For example, like this. We have two key scripts, player move and prefinish behavior, right? Player behavior is responsible for switching between them. Let's see again. This trigger here activates. Player behavior refers to it and calls the method. Start prefinish behavior, right? Great. Actually, this huge gray box looks a little strange here. We'll hide it later. We'll disable the mesh renderer, but in tests, it'll be convenient for you to see approximately where it all starts and what causes bugs. So I suggest creating a new transparent material. I'll call it trigger. I'll put it on this object, and you can set the surface type to transparent here. Then you can adjust the color transparency like this and make it half transparent. This is just for our own convenience. Let's see what happens. First, we need to make sure that all the links are assigned and there are no empty fields. The character runs, develops, and I can't control them any longer, they just run forward. But there's a small problem. First of all, they have to run in the center. Collecting coins, that is, they should move smoothly toward the center. The second problem is that they have to turn smoothly in the forward direction. Let's write it all. I'll open the player script. Here's prefinish behavior. In the update, let's describe how they should move in detail. This is the code I wrote. Let me explain. We use an interesting method that's called move towards. It gradually changes the player's position from the current value to some target value. We take the current position along the x-axis. Now it's there on the road, and we gradually shift it to 0. This third parameter indicates how much the value changes per frame. The character will move towards the center at a speed of 2 meters per second. I created the z variable. It's just the character's position in the next frame. Then we assign these two values to their position, and they'll move forward and gradually get closer and closer to 0, to the center. This part is responsible for the angle of rotation. First, we calculate the angle, and then simply assign it to the player's transform. We're interested in the angle to the y-axis. I also use move towards here. There's also the move towards angle method. It's better suited for angles, but if you measure angles, minus 360 degrees is the same as 0 and the same as 360 degrees. But if you don't think of these numbers as angles, strangely, they can approach 0. They're like this. So you have the regular move towards, but if you want to work with corners, you need move towards angle. Here, we turn the character at the speed of 100 degrees per second, so that they run forward in a straight line as a result. Let's take a look. I can run into the strangest corner, but the character turns in the right direction just like that. They may run a little sideways, but I think this behavior is completely acceptable in a casual game. The last thing to do is to make the character reach the finish line, win, and start to dance. The finish also uses a trigger. I'll copy this trigger. I'll drag it here, and now let's write another small script. Let's call it finish trigger. And name the object the same way. It's convenient to name objects the same as scripts, especially if there's only one relevant object in the scene, so you can find it quickly and easily. Finish trigger. Its behavior will be similar to pre-finish trigger, so you can basically copy this part of the code. We'll just change it a little. What changes is that we call the start-finish behavior method instead of start-pre-finish behavior. But this method doesn't exist yet, so let's create it. In the player behavior script, we create a new method, public void start-finish behavior. So what needs to happen here? First of all, this thing here has to turn off. They have to stop running. Secondly, they have to start dancing. To make the character dance, we can add a link to the animator. We need to refer to the animator. Let's remember how it works. The player animator. It was such a long time ago. The player has a character model. There's an animator component in it, and an animator controller in the component. We set up the parameters here. Yes. First, depending on whether the run option is selected, the character can run or not run. This arrow points to dancing. The character dances if the dance trigger is activated. Here's the dance trigger. How do you work with it? We need to take the animator, call the setTrigger method, and write the trigger name in quotes. Make sure you write in the correct case. Because it uses a capital letter here, it must be the same there. That's basically it. Let's take a look. They aren't going to make it again, are they? Because we need to. Make the character larger. When we set up the level balance, we'd better make it impossible for the character to get so big. Something didn't work, you see? Let's find out what happened. The trigger is on. Why didn't they stop? Because of the finish trigger. Of course, I haven't edited it yet. Or rather, I just forgot to save it. This happens from time to time. You can't understand what's wrong for a long time. Everything seems correct, but in fact you just forgot to save the script. Keep in mind that there's an option to click the icon with 2 floppy disks, not the icon with 1 floppy disk. Then you save all the files that you have open here, because sometimes you work in one file and forget to save the other one. When you interact with several scripts at the same time. I forgot something again. Of course, I forgot to assign the animator here. So the character reaches the trigger, stops, and starts dancing. Now there must appear a window where it says you won, and the next button. In conclusion, I recommend that you create small scripts, each of which is responsible for a separate small action.